What about ordinal variables? So what are our observations in case of two ordinal variables? Let us call these two variables x and y. And so what we have a sample of n observations. So we observed n objects, n people, or n things, n items. And for each item, for each observation, we know its rank with respect to x and its rank with respect to y. So Ri is the rank of the ith observation when sorted by x, and Si is the rank of the ith observation when sorted by y. And so for each observation, we have pair of numbers. So Ri, Si, its rank. For each observations, we have two ranks. So what is done next? We calculate the coefficient that is called Spearman's rank correlation coefficient, or just Spearman's coefficient, or sometimes it is called Spearman's rho, as the standard way to denote this coefficient is Greek letter rho. And symbol that is used for this coefficient is rho s. So s is for the for Spearman's name. So the formula it is calculated with the formula you can see now. So first step is to find sum of squared differences of ranks, and then so this Spearman's rho is 1 minus 6s divided by n cubed minus n. So, and this coefficient can take values from -1 to 1, and it shows us how strong the monotonic dependence, monotonic relationship between x and y is. So if this coefficient, if rho s is equal to 1, this means that there is a direct monotonic relationship between x and y. So this means that if you know that for a pair of objects, so that the first object is greater than the second one when sorted by x, this means that it will be greater than, the first will be greater than the second when sorted by y also, automatically. Like, for example, if you know that someone's income is higher than someone others, this means that sum of taxes they pay is also greater, also higher than the sum of taxes of that other person. So if income is higher, then taxes are also higher. So automatically, for these two variables, so income and taxes, sum of taxes paid, this rho will be equal to 1. So we have a direct monotonic dependence here. -1 means inverse monotonic dependence. So this means that if one observation is higher than the other, greater than the other with respect to x, it will be less than the other with respect to y automatically also. And so 0 means no monotonic dependence. So the physical meaning of the Spearman's rho is the how strong the monotonic dependence, monotonic relationship between x and y is. So sometimes it is enough just to calculate this coefficient, to say that rho is like 0.75 or rho is minus 0.3, and so it's enough to understand the situation. But sometimes we are interested in hypothesis testing. So sometimes we want to test a hypothesis that rho is 0, the theoretical rho. So what we calculate with this formula is rho hat. Rho hat is sample rho, sample Spearman's coefficient. And there is also a theoretical one, and so sometimes we want to test a hypothesis that theoretical Spearman's coefficient is 0. This means that there is no monotonic relationship between x and y against one of the alternative hypotheses. So you are to choose just one of these three, either rho not equal to 0, or rho greater than 0, or rho less than 0. So this means that there is a monotonic relationship, that there is a direct monotonic relationship, and that there is an inverse monotonic relationship. So the test statistic is based on the Spearman's rho, on the sample Spearman's coefficient, and so the formula for the statistic is square root of n-1 times rho hat. And Spearman proved that if HO is true, then T follows standard normal distribution. So that means that the situation for critical regions and for the p-values is absolutely the same as in plenty of our previous tests. So critical region depends on the alternative hypothesis. For not equal sign, it is two-tailed. For greater sign, it is right-tailed, and for the less sign, it is left-tailed. And so formulas for the p-value are also the same, so as usual, and we use the standard normal CDF to find the p-value, as the test statistic follows standard normal distribution. Now let us see what can we do with ordinal data. There is a class of 10 students, and the math teacher ranked these students in order of their mathematical abilities from the lowest to the highest. So they are, the ranks are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the music teacher was asked to do the same, and he also ranked the same students. And so ranks of the music teacher are 6, 5, 1, 4, 2, 7, 8, 10, 3, 9. So the question is, can we assume that there is a relation between mathematical and musical abilities? So can we assume that there is a relation between mathematics and musical abilities? So what are the hypotheses we are going to test? The null hypothesis is always that Spearman's rho is equal to 0, theoretical value of the Spearman's rho. This means that there is no monotonic relationship. So no monotonic relationship between x and y, between abilities for mathematics and for music. And as for the alternative hypothesis, we can choose either not equal or greater or less. And let's have a look. What did they ask? They asked can we assume that there is a relation between mathematical and musical abilities? So this means that they don't ask us if, is there a direct relationship or inverse relationship, inverse dependence. So maybe the better the better is the student at mathematics, the better he or she is at music. Maybe vice versa, the better the one is at mathematics, the worse he or she is at music. So they don't have any ideas about this. So let us also say that the alternative hypothesis is that rho is just not equal to 0, and that's all. And this means that there is a monotonic relationship of some kind. So that there is a monotonic relationship. So then we need to find the sample coefficient and the test statistics. So the first step is to find S, sum of squared differences. So it is like 1 minus 6 squared plus 2 minus 5 squared plus 3 minus 1 squared, so on, up to the last 10 minus 9 squared. And if we calculate all this, we'll get that this is equal to 90. So then the next step is the sample Spearman's coefficient. It is 1 minus 6 times S, that is 90, divided by the n cubed minus n, and n is 10. We have 10 observations. 10 cubed minus 10. And this is approximately equal to 0.455. So we see that coefficient is very close to 1/2. This means that there is a direct dependence, direct relationship, and it is not so very strong, but not so very weak. So its coefficient is between 0 and 1, so of medium, so when we are asked how strong this relationship is, we can say that medium. So now, that means that we can say that the better is student at math, the better he or she is at music, and vice versa. So then, on average, it's better to say so. Not the better one is at math, the better he or she is at music. It was not an accurate expression. It's better to say, so on average, the better one is at math, the better he or she is at music. So then, the next step is to find the test statistic. So the test statistic is the test statistic of the Spearman's test is square root of n minus 1, that is 10 minus 1 in our case, times the rho hat, times 0.455. And this is approximately 1.37. Now we say that under null hypothesis, so if HO is true, then we can assume that the distribution is standard normal. And so we can use the quantiles of the standard normal distribution for the critical regions. As we have not equal sign here, we have two-tailed critical region. So here we have Z alpha over 2, and here we have Z 1 minus alpha over 2, and this is the critical region, this is the acceptance region, this is the critical region. Let us assume alpha being 0.05, standard alpha. And so in this case, this is the quantile of the level 0.025, and this is the quantile of the level 0.975. We can use the table, and we can find that this is minus 1.96, and here is plus 1.96. And what do we see? Then we see that in spite of the fact that the coefficient was close to 1/2, so pretty different from 0, we see that the test statistic still is in acceptance region, so it is somewhere here. So t, that is equal to 1.37, t falls to the acceptance region. This means that the null hypothesis is accepted, not rejected. So t belongs to the acceptance region. This means that HO is accepted. We fail to reject, or we can say that we fail to reject HO. That is why it is accepted. And so what is HO? HO is that there is no monotonic relationship. So if we are asked, can we assume that there is a relation between mathematics and music abilities, it's better to answer no in this case. No, we can't. So the answer is no, we can't at the 0.05 significance level. So why this happens? So it seems to be a little bit strange. So the coefficient is quite different from 0. It's not like 0.02, 0.07 and something like this. It's 0.45, almost 1/2. And in spite of this fact, we assume, we accept the hypothesis that there is no relation. How this can be true? This is because of the small sample. So, for example, if you have just, I don't know, just 2 observations, the coefficient can be even equal to 1, but still this won't be enough to reject the null hypothesis, because so the sample size is too small to say that that this cannot happen just accidentally. So this situation, the reason why do we have such a situation? Sample raw so different from 0 and HO accepted at the same time is the small sample size. We have only 10 students, so it's better. So we would recommend those I don't know, psychologists or who who perform such tests. So to test not 10 students, but let's say 100 students, and then we will get more significant result.